Hello everybody, this is our 2.5 Atoms with Charge video. The objectives for this video is to talk about factors that determine an atom's atomic charge, and then how to represent this charge using isotopic notation. So the first thing we want to talk about is what is an ion? An ion is any atom that either has a negative or positive charge. So that means that the number of protons and electrons are uneven. So what causes an atom to either have this charge? And how can you tell if it does have a positive charge or if it has a negative charge? So going back to our subatomic particles, we know that the only two subatomic particles that actually have a charge are our protons and our electrons. Neutrons are just neutral. They don't have a charge. So charge is determined by the number of protons and electrons inside of an atom. So once we know that charge is determined by protons and our electrons, how can we determine what the charge is going to be? So we know that if we have more protons in an atom than we do electrons, our overall charge is going to be positive. Also, if we have more electrons, which is more of a negative charge than we do our protons, our overall atom will become negative. Once we figure out that protons and electrons contribute to charge, we need to figure out how to determine what the exact charge is. So I want to give you an example of a game. It could be any type of sports game or anything like that. So pretend the Bulldogs were playing and the ultimate score of the final game was the black team scored 6 points and the gold team scored 5 points. A normal assumption to make, and people say this all the time, you can say that the black team wins by 1 because they scored 1 more point than the gold team. So if we relate this to atoms, if we count up the number of protons and we determine that the number of protons is 6, and then we count up the number of electrons and we determine that number is 5. A normal assumption to make is you can say that the proton wins by 1. So that team scores 1 more point than the electrons. So because our protons are 1 point more than our electrons, our overall charge is a positive 1 charge because protons are positive and electrons are negative. Another example is pretend now that the black team scored 2 points and the gold team scored 6 points. An overall assumption to make, you can say that the gold team wins by 4. If you relate that to atoms, you have 2 protons and you have 6 electrons. You can say that the electrons win by 4. So that means the overall charge is going to be negative 4 because electrons scored 4 more points than our protons and electrons are negative, and therefore the charge is going to be negative 4. So now that we talked about how to determine the exact charge, let me give you an example of this atom of lithium. So you count up the number of protons and you see that you have 3 protons. You should be taking score at this point when you have an image that looks like this. When you count up the number of electrons, you see that there is 2. So therefore, you can assume that the protons win by 1. So the positive team wins by 1. Overall, you're going to have a lithium atom that has a positive 1 charge. Another example is this nitrogen atom. You count up the number of protons and you see that you have 7 protons in this atom. You count up the number of electrons and you see that you have 10 electrons in this atom. So our negative team wins by 3. Therefore, this nitrogen atom has an overall charge of negative 3. So once we figure out what the charge is, how do we represent it using isotopic notation? So if you remember from our previous videos, this is how you write isotopic notation. The charge goes in the charge box, which is written at the upper right-hand corner in isotopic notation. And these are our 2 key points. So if there's no charge written in that charge box up there, then we can assume that that atom does not have a charge. So therefore, our number of protons are equal to our number of electrons. Lastly, let's just do a quick example when we're talking about two isotopic notations of sodium and trying to figure out which one's neutral and which one has a charge. So the one on the left, you can see that your atomic number tells you the number of protons that are in a given element. So we have 11 protons in this atom. When we look at the charge box, there's nothing written there. So we can assume that this atom is neutral, and therefore it has no charge because our number of protons are equal to our number of electrons. On the example on the right side, you can see that our atomic number is 11, and that is how many protons we have in this example. And then the number of electrons is going to be determined by that charge. So we can see that we have a positive 1 charge. So what that means is that the positive team is winning by 1. And we know that our number of protons can never change because that's our atomic number. So sodium is always going to have 11 protons. Therefore, that means our number of electrons has to be 10 in order for the positive team to win by 1. Overall, that means that our charge is going to be positive 1. This is just a quick recap of all the things we talked about in this video. Thank you for watching.